When we think of stars, we often picture small, sparkling points of light in the night sky. This is how we typically perceive them from Earth. However, stars are far more complex than they appear. One of the most fascinating examples is Betelgeuse, a star that is much larger than our Sun. For years, this star has intrigued astronomers, but recently, Betelgeuse has shown troubling signs, raising concerns among researchers and science enthusiasts alike. In this video, we'll explore the latest developments regarding Betelgeuse, its impending destruction as revealed by the James Webb Space Telescope, and what this discovery might mean for our galaxy and life on Earth, as explained by physicist Michio Kaku. Betelgeuse is a giant, red supergiant star located in the constellation Orion. It has captivated astronomers for centuries, with its discovery dating back to ancient Greece. This star is so massive that it is visible to the naked eye in the night sky, especially during the winter months. If you enjoy stargazing, you may have noticed the reddish-orange glow of Betelgeuse marking the upper left shoulder of Orion. Despite being one of the brightest stars we can see, Betelgeuse is an unusual star. Unlike most stars, its brightness fluctuates. This variability is one of the star's most fascinating properties, but it's not the only interesting feature. Let's take a closer look at some of Betelgeuse's unique characteristics. Most stars are far from Earth. For example, the closest star to us, Proxima Centauri, is 4.2 light-years away. To help understand the vast distance, imagine traveling at the speed of light for an entire year. Light travels at a speed of 186,000 miles per second, covering about 5.88 trillion miles in 1 year. So, when we say Proxima Centauri is 4.2 light-years away, it's still billions of miles from Earth. Some stars are even farther, including Betelgeuse, which is located about 600 light-years away. If you could travel at the speed of light, it would take you 600 years to reach it, far beyond the capabilities of our current technology. Despite its distance, Betelgeuse shines incredibly brightly in the sky. This is due to its immense size and brightness. Betelgeuse is roughly 500 times larger than the Sun, with a radius that is about 1,000 times that of our star. While many stars appear as small points of light through telescopes, Betelgeuse appears as a distinct disk, likely due to the reactions occurring in its outer layers. It is estimated to be between 12 to 19 times more massive than the Sun, though its exact mass remains uncertain because there are no orbiting planets to help scientists measure it precisely. However, even with this uncertainty, it is clear that Betelgeuse is much heavier than the Sun. Betelgeuse's luminosity is another key feature. Its brightness varies between 10,000 to 16,000 times that of the Sun. As a result, it is often referred to as a red giant. The star's luminosity fluctuates because of its expansion and contraction. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These changes can last anywhere from 10 days to several months. One remarkable characteristic of Betelgeuse is the presence of dark magnetic spots on its surface. These spots, much larger than those on the Sun, prevent the flow of hot gas, causing the affected regions to be cooler. This magnetic activity, along with the star's enormous size, contributes to Betelgeuse's relatively low surface temperature of around 3,500 Kelvin, which gives it its reddish hue. Betelgeuse wasn't always a red star. In fact, it used to be yellow, much like the Sun. Over time, as the star aged, it shifted to a red color, signaling its transition into a red supergiant. This change has led astronomers to believe that Betelgeuse is nearing the end of its life. Despite its tremendous size, Betelgeuse is not the largest star known. There are stars out there that surpass it in size, but its massive radius and varying brightness make it one of the most intriguing stars in our galaxy. If Betelgeuse were closer to Earth, it would easily outshine the Sun, potentially even displacing or swallowing the Earth and other planets in the solar system. Betelgeuse's size and brightness make it a standout in the Orion constellation, located 600 light-years from Earth. If it were just a little closer, we would likely see it during the day. However, its current distance prevents it from having the same effect on Earth as the Sun does. Were it to replace the Sun, Betelgeuse would easily consume the orbits of Mercury, Venus, Earth, and Mars due to its sheer size. In addition to its massive size, Betelgeuse emits far more radiation than our Sun, making it a much more dangerous star if it were any closer. Betelgeuse's extraordinary characteristics have made it a subject of intense study for astronomers. Although it's not the most massive star, its size and luminosity make it a remarkable celestial body. Researchers continue to monitor Betelgeuse's fluctuations and its eventual fate. As we learn more from the James Webb Space Telescope, we may uncover even more about this fascinating star, including how its death could impact our galaxy. Betelgeuse, the famous red supergiant star, is unmistakably recognizable for its rosy or orange tinge, which can be observed through spectroscopy. This technique uncovers absorption lines that reveal the star's composition, including hydrogen, helium, and heavier elements created through nuclear fusion deep within the star. Betelgeuse also exhibits significant magnetic activity on its surface, marked by dark magnetic spots, regions where the star's magnetic field is much stronger than the surrounding areas. These magnetic features disrupt the normal convection processes that transport heat from the star's core to its surface, causing cooler regions to appear on the surface. The study of these magnetic phenomena provides valuable insights into stellar magnetism and its effects on the properties of massive stars. Betelgeuse has been known for centuries, with ancient astronomers from various cultures, including the Greeks, Egyptians, and Chinese, recording its position and observing its fluctuating brightness. In Arabic astronomy, Betelgeuse was named Yad al-Jabiyeh, meaning the hand of Orion, reflecting its prominent position in the constellation. The star's changing luminosity has inspired numerous legends and cultural references over time. In Greek mythology, for example, Orion the hunter is depicted with Betelgeuse marking his shoulder, and its variations in brightness were often interpreted as signs of strength or mood, influencing beliefs and stories across different civilizations. Despite its cultural significance, Betelgeuse has also been a focal point for scientific study. Observations using telescopes and spectroscopic instruments have provided detailed data on the star's size, mass, temperature, and chemical composition. These studies have contributed significantly to our understanding of stellar evolution and the life cycles of massive stars. In late 2019 and early 2020, Betelgeuse experienced unusual dimming events, with its brightness significantly declining. This sudden change in luminosity sparked intense speculation among astronomers, with some theorizing that Betelgeuse might be on the verge of a supernova explosion. A supernova occurs when a massive star exhausts its nuclear fuel and undergoes gravitational collapse, leading to an explosion that releases an immense amount of energy, making the star one of the brightest objects in the night sky, even visible during the day. The possibility of Betelgeuse undergoing a supernova has captured both public imagination and scientific interest, particularly because of the star's proximity and visibility. Astronomers continue to closely monitor the star, using both ground-based telescopes and space observatories to gather data on its behavior and evolution. As a red supergiant, Betelgeuse plays a crucial role in the later stages of stellar evolution. During these phases, heavy elements such as carbon, oxygen, and iron are synthesized in the star's core. Studying Betelgeuse and other similar stars helps astronomers understand how stars evolve and how they contribute to the chemical enrichment of the universe. The process of stellar nucleosynthesis in massive stars like Betelgeuse is responsible for the creation of heavy elements that will later form planets and life. Betelgeuse's variability and complex behavior challenge astrophysical models, and understanding the mechanisms behind its fluctuations and brightness changes requires sophisticated simulations and observational techniques. By testing and refining these models, astronomers improve our understanding of stellar processes and their broader implications for cosmic and galactic evolution. Future observations of Betelgeuse will continue to play a critical role in advancing our knowledge of stellar development and supernova phenomena. Long-term monitoring using ground-based observatories and space telescopes will provide real-time data on the star's variability, magnetic activity, and potential for a supernova event. Advances in observational technology, such as next-generation telescopes and adaptive optic systems, will allow astronomers to study Betelgeuse and other distant stars in unprecedented detail. These innovations will enable deeper exploration into the mysteries of stellar interiors and atmospheric dynamics. Combining observations across different wavelengths of light, from radio waves to gamma rays, will offer a comprehensive view of Betelgeuse's physical processes and interactions with its surrounding environment. Multi-frequency studies are crucial for unraveling the complex interactions between magnetic fields, stellar winds, and the interstellar medium. In conclusion, Betelgeuse remains a cornerstone of astronomical research, offering invaluable insights into the life cycles of massive stars, cosmic processes, and the origins of the chemical elements in the universe. Its variability, cultural significance, and potential for a supernova event make it an intriguing subject for continued and future studies. By further investigating and observing Betelgeuse, astronomers will continue to enhance our understanding of stellar evolution and the dynamic processes that shape the universe. Betelgeuse, a red supergiant star located in the constellation Orion about 600 light-years from Earth, is a remarkable celestial object. It stands out due to its massive size, variability, and the changes in its brightness. Unlike our Sun, which maintains a steady luminosity, Betelgeuse exhibits dramatic fluctuations in its brightness over time. These fluctuations are attributed to internal pulsations within the star, which cause it to expand and contract. When the star expands, it becomes brighter, and when it contracts, its brightness diminishes. These cycles can last anywhere from days to months, contributing to Betelgeuse's dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for a star of its size, around 3,500 Kelvin, giving it a distinct reddish-orange hue typical of red giants in the final stages of stellar evolution. Having exhausted the hydrogen fuel in its core, Betelgeuse has entered the phase of stellar development where it begins to fuse heavier elements. This fusion process releases energy, causing the star to expand outward. The star's outer layers exhibit some unique physical phenomena, such as large, dark magnetic spots on its surface. These spots, which are much larger than those found on our Sun, represent regions of intense magnetic activity that prevent hot gases from rising to the star's surface, creating cooler areas. Betelgeuse's historical and cultural significance is also noteworthy. It has been recognized by various civilizations throughout history, particularly due to its visibility in the winter sky in the northern hemisphere. The star's role in folklore and star constellations adds to its prominence. More recently, Betelgeuse has garnered scientific attention due to an unusual dimming event that began in late 2019 and lasted into mid-2021. During this period, its brightness dropped significantly, sparking speculation among astronomers about the star's fate. Betelgeuse is one of the brightest stars visible to the naked eye, but its variability makes it a subject of ongoing study. Despite its immense size, roughly 500 times the radius of our Sun, it is not the most massive star, with estimates of its mass ranging from 12 to 20 times that of the Sun. When compared to our Sun, Betelgeuse is much larger, and if placed at the center of our solar system, its outer layers would extend well beyond the orbit of Mars. At its peak brightness, Betelgeuse can shine up to 16,000 times brighter than the Sun, but during dimming events, its luminosity can drastically drop. This variability provides astronomers with valuable insights into the star's life cycle and the behavior of massive stars. Understanding the mechanisms behind Betelgeuse's brightness fluctuations is crucial for unraveling the complexities of stellar evolution and the behavior of stars in their later stages of life.